Okay, we're going to look at a second lesson on parametric equations. Let's say that you got asked to change a pair of parametric equations, which we already know are the unit circle, but let's go with it anyway. Let's say that you were asked to change them into a Cartesian equation. How would I go about that? And the answer to that question is, you would simply say, call that one 1, like simultaneous equations, call that one 2, and we're going to substitute 1 and 2 into the Pythagorean identity, which we just learned about in the previous lesson, so in the previous video. So here's the Pythagorean identity. There it is. We're just going to substitute, and we want to get a Cartesian equation which can no longer have theta in it. So that can't exist in the final thing. We just want x and y in there. So we're going to substitute cos theta in here. Now remember, cos squared theta really means this, cos theta all squared. And sine squared theta means the same sort of thing. So we're going to put cos theta, well, what does cos theta equal? Cos theta equals x. So that brackets becomes x, and then it's squared. Plus sine theta all squared, that becomes y. So you get y, and then 1 just stays 1. And so we've done it. We've now got a Cartesian equation. And you can see that it's got a radius of 1, and that's the unit circle. So from parametric equations to Cartesian equations. What about a slightly more complicated one? Change x equals 5 cos theta, y equals 5 sine theta. I wonder what that means for what type of result it's going to be when we change it to a Cartesian equation. Well, in this case, we have to just do a little bit more groundwork. Because that 5's there, that just complicates things a tiny bit. What we need to do is we need to make cos theta the subject of that. So we'll call that 1, call that 2. And we're going to say from 1, cos theta equals x over 5. And from 2, sine theta equals y over 5. So there's the two new results. We'll call them 3 and 4. So basically the rest of the question is like that. Substitute 3 and 4 into this Pythagorean identity. And by now we know that the squared there really just means brackets and a square out the back, but that's the notation for it. So we're going to get part 3, and we're going to substitute it in there, so it becomes x over 5 all squared plus y over 5 all squared equals 1, nearly to the finish. That's x squared over 25 plus y squared over 25 equals 1. And since I'm going to run out of space, I'm just going to write my final answer in this box over here. And we can see that that's going to give us, when I times both sides by 25, x squared plus y squared equals 25. So it is in fact what we started with up here. The parametric equations there are for a circle, centre 0, 0, and radius 5, which is shown out by the 25 when you take the square root.